Okay, so explanation in this series of lectures in the client-server architecture and model. We have spoken, so let me repeat what I have talked about last time. We talked about a client and the server, they communicate together. This is part of an echo server. I showed how the client will have its own socket called the client socket. The server will have a socket, I call it the server socket. And then I have two variables here for input output. This is the out, which allows the client to write into the socket. This is the in, which allows the server to read from the socket, and so on. So I talked about this at length. So let me, since you have already had a session with the teaching assistant on how to write a client and a socket, let me go over that in at least where we have been. So you already have seen this statement. This is how we create a socket in Java. We simply use the class socket. This class is already imported. So we import from Java the data input stream. I will talk about that in a second. This is the main one. You import this class. This is for that allows you to use the built-in Java socket class. So after importing this, making sure that we have this class in our header in our, and this is, by the way, our client. This is our client.java. This is our client class, if you will. Now, as I said, this statement right here, when I say socket client equal new, I am opening a new socket. Okay. Now the name of the socket is client. It belongs to the class socket. I define two parameters: localhost. This is the address of the server. That's where the server is going, because this client is going to communicate with a socket which is located at the local host. Now, if the server was at a different place, then what I will be doing instead of this, let me for a second write this and then I will delete it. It will be probably be 78.65.120.7. This is an IP address. This would be an IP address on a different host. But since I am using the local host, I will just say local host, meaning that the server is in the same at the same host as the client is. And 2000 here, this is a port number which is being used by the server. So the server announces the port number, which is number 2000. The client will use this port. Okay. Now, in order for this to be true, to be valid, let me switch here to this place where this is the server class. Similarly, in the server class, let me just go right here. This is how the server socket is being introduced and declared. I use the class server socket. The name of my socket is server, and I define it as a new server socket. So this is the server socket. I define it, and I define the port number. This is 2000. Now there are different ways, there are different methods of defining more parameters, things that have to do with the threads, with locks, with many other things. We'll talk about them later, but for now we will define my socket, my server socket being called server, and it is of the type server socket. It is of the type server socket, and it is using port 2000. Note that this 2000 is exactly the same as this one. So if I were to define let's say port 4450, then I will define in the client here, I will change this to 4450. So this will become my port number, the port number which I use to communicate with the server. So let me keep it at 4450 for now. Now, for the server, we'll have to define. Now, this is, remember, this is the socket that allows the server to act as a server, and this is defined by the server socket, which is a Java class. Now, within this server, I need to define an internal socket, if you will. I will call it socket client. This socket client is going to accept a communication coming from here, from this guy. Now, I will switch to explain this in a different manner. So now when I say client says a new socket, which means open a socket, open a communication port to the local host at port 4450. Who is 4450? This guy is 4450. Okay, who is going to receive this call from the client? Oh, this statement here, it's going to receive it. Now, let me show that in a more visual term. Let me switch to PowerPoint and show exactly how this is going to work. Now, and this is how I will do it. Okay, let me put a shape here. This is a line, and this line is going to be my client, if you will. So I'll call this client. That's my client. And this is my server. I'll put it right here. Okay. This, what I am doing here, actually is called the inter-process communication. So now this inter-process communication, how do I do that? Okay, anyway, let me just put it this way. With insert text box, I will call it inter-process communication. Now remember, the client is a process, this is a server. The server is a process. Now here I did the statement. I will copy actually this statement, which I have it right here. Actually, I will copy it exactly as is. And where is my text box? Oh, sorry. Okay. So at this point, and let me do it as a point here. What is my shapes? Okay, so at this point I will say socket. The client will say a new socket to localhost. Now this server, this is the localhost, and I'm using the port number 4450. Okay, now when I do this statement, when I write client equal new socket localhost, actually what I am doing, let me show exactly. This comes from here. Okay, to this location. Now this location, and let me take this. This location in the server, this is exactly this statement right here. This statement Okay, actually it's right here, it's above that. So the statement from the server which says socket client, actually let me change the name here from client, I will call it client 1 because I want to distinguish this from the socket name at the client, because these are two different sockets. So this is called client 1 and actually this becomes client 1 right here. Okay, so the server executes the statement server.accept. So I am going to accept a call from the client. I am waiting right here, and the server will keep waiting for a communication that comes to port 4450 coming from any client, from anyone who knows the port. For now, this is the client which we have created is going to use the socket which is called client, and once you do the word new actually opens a socket and sends a request. This line right here, it is called a request to connect. Let me write it here on this. This is a request to connect to server at port number 4450. So this line actually it's a request to connect. Now we did not write this request. There is nowhere in this. Let's go back to our program here, the one you are writing or you are using. When I did this, when I said new socket localhost 4450, I have just drawn a line right here, and you see that this line, it says I'm sending a communication connection request to the server at port number 4450. We did not write this. This is actually carried by the TCP IP. This is carried. This is organized by the TCP IP. Once you do the new socket localhost 4450, once you have done that, then there is something hidden which you do not see, which says sends a communication line to the server. The server is waiting now at its port. There is a port here. Actually, let me show this right here. This is my server. It will be waiting for this signal to come. It's waiting, and once it comes, once the signal comes, which is this line, once it comes, then the server will either accept or reject. It depends. Now, if the server has written, or we have written the statement, socket client 1 equals server.accept any request to connect, there is going to be an accept statement. Once you say the accept, there will be a line coming this way. So and I will do it here. I'm not going to do it right there. Okay. And the line here, which is, bear with me, let me show this. How do I show that? I want this one. Okay. Now this time right here, from here to here, and of course, so that it becomes more here, and let me okay. Now this is my accept statement. This is accept connection, accept connection. So this accept connection is executed by the underlying system and the server. And this, as I was trying to say, this guy here, this time, what is this time? So that we understand exactly what's going on. This is the time needed. Whoops, sorry. This is time needed for the server to accept the incoming connection, request from the client. So this is the time. Now, of course, you could tell this time has nothing to do with communication, but nevertheless, it's part of the underlying communication and networking protocol. Now, this could be, okay, this time could be microsecond, 2 microsecond, it doesn't matter, but this is a time. And in our system, once we do some question on this issue, we will say how much time does it take. And once this time is has been executed, so the server decides to accept the connection from the client, then a message will be sent to the client saying accept connection or connection request accepted. So there is connection, let me write it better, connection request accepted. Okay, now only after this time that the client can continue to work. Let me show that what I mean. This is my client right here. Okay, I say this is socket client. Once, let me put right here a statement, any statement. I will say print, let me just say, copy this guy here, right here. Okay, system output line, say the server has accepted my request. Okay, that's all. And okay, now guess what happened here? Oh my god. All right. Now what I have written here, I added a statement. This is my statement. Let me put it in bold. No, it doesn't work right here. Okay, that's my statement. I requested the connection. The server decides to accept my connection. The server sends the connection request accepted. And here I just made this statement system out.println line. The server has accepted my request. This statement will only be printed on the screen. You will see this. Only here. So this elapsed time, okay, from here to here, this is the waiting time for the server to respond. And this is a very important criteria which we have to, where are my shapes? Okay, so this time, Okay, this time from here to here, this is waiting time. This is the time this is here. Let me write it. Okay, here is the client is waiting for the server to accept the request. Okay. All right. So this is this guy right here. Let me put it in red. I am waiting. The client is waiting for the server to accept. Actually, the client is doing nothing, absolutely nothing. Now, why this time is important? Assuming that the server here is too busy. Okay, I send the request, the server is too busy. Server is not ready to accept the connection from the client. There is the statement socket client 1 equals server dot accept, but it does not. Let me actually, to be more accurate, it should be somewhere right here. Okay, I'm not ready to accept this. I'm busy. I'm too busy. Why am I too busy? I'm too busy. There are all types of reasons why the server will be busy. The server has a database. There are many clients. It's serving 1,000 clients, and this is only one of them. So it takes time until it comes around and executes the statement. So this time here, I will call it this time, call it T underscore accept. If this T accept, it happens, so let me if this T accept, if T accept is too large, then the session might expire. There is a new term here. I have a session. Which session might expire? Now the server is busy doing a million things. The server doesn't care about the client, whether it accepts it or rejects it, whatever happens to the client happens to the client. يعني شو اللي بصير للكلاينت بصير للكلاينت. The server ملوش علاقة في الموضوع. If T accept is too large, and let me put it right here then, let me move this way, okay, like this. Oops. Okay. So the client sends the request and the server takes too much time to respond. So the elapsed time from here, this time here is, I will call it T initial. This is my initial time, or I will call it T request. That's better. Okay, now this T right here, now this is T, that's the server time. This is the server waiting time. Server is waiting until it accepts. And this time here from, let's do it a little bit bigger so that it can be more visible. This elapsed time from here to here, this is communication time. This from here to here, it's communication time. Okay, that's communication time. That has nothing to do with the server, has nothing to do with the client. This is communication time. This is also right here, it's also T communication from here to here. So we can appreciate the time. This is also communication time. That's the time it takes the request to come from the client to the server. If the client and the server are on the same host, so it's not big deal, it's almost trivial, it's really nothing. Similarly, this time will be nothing. Usually this T communication and T communication are equal, so they, although they look not, they don't look equal on the slide, but they are really equal. So this is a time, this is a time. There is a processing time within the server, it's a waiting time depending if the server is busy or not. So if you add T communication plus T communication back and forth, and you add the processing time of the server, all of this time here, which is this all the way, I will call it T total, this, okay, T total will equal 2 times T communication, because I have 2 communication time, plus T server processing time. Okay, so this time T total from this, which is equal this, so if I call I'll call this T end, this T total actually equal T end minus T request. Okay, from T end minus T request is this time, and which consists of 2 communication times and server processing time. Now this T total, the important of this thing here, it has to be equal or less than the TCP IP session. Remember I said TCP has a session. If the TCP session expired, all of this here, this communication, this line and this line, all are carried within the same TCP session. So when the client attempts to make a request to connect using the new socket, it is going to open a new TCP connection or TCP session. This TCP session usually has, so this here, let me write this T total must be equal or less, preferably less than the T, that call it TCP session time. Now this TCP session time, by the way, it is a configurable parameter within the systems. If you open your system and you look for the TCP session, usually this is here, it is set to around maybe 500 milliseconds, typical. So it's about 1/2 second. So it allows you 1/2 second. Sometimes you put it to a little bit larger, make it, let's say 750. As sometimes you make it open and limited, just take as much time as you want, but that's dangerous, because if you keep the TCP session open for an unlimited amount of time, you are going to run into all types of synchronization problems, communication problems, and you can waste the resources. So the system usually configures the TCP session to some very limited amount of time, let's say within 1 second or half a second or 3/4 of a second. If that's the case, then you better have the request go to the server and come back before the TCP session expires, and then you are set to go. So to conclude the story here, for at least for this part of the lecture, remember, this is at the client where you write this statement here, okay, and so you do your socket, client new socket localhost, you go to 450, okay, then this means that you send a request to the server. The server is waiting at this place here, which is called the socket. Let's put this in blue. Not good. Not good. What color? Let's do this color. Make it bold and increase it. Okay. So this on the server side, which is here. Actually, it comes from here. Socket client1 equals server dot accept. So if the server actually accepts the statement, and after processing some time and there is a waiting time for it, then you do the accept, then a message will be sent back to the client, and this message will take time. It's not immediate. You cannot simply do it this way, because it's not momentarily. It takes time. And by the way, the time it takes to send this message here, it depends on two parameters. One parameter, how fast you can push this message which says I do accept the request from the client, which carries a certain message, and you push it across the Ethernet link or the Wi-Fi. There is time there, and I will explain that later. And of course, the propagation delay. The propagation delay depends on the speed of light and the distance between the client and the server. If the distance is on the same, if the client and the server are on the same host, then the time is 0. Otherwise, the time is not 0. So I will conclude this explanation on the actual communication between the client and the server and what could go wrong. Now, going back here, let me just go back to the server one more time. Remember that's the reason I said this is client 1. In fact, as I will explain later, the server can define more sockets or more acceptance to more clients. It can do, I can accept client 2 on the same socket, which is this guy or this server. My server is a socket. That's the primary socket, the primary server socket. This is the main one. And within this, I attach to this socket client 1, client 2, client 3, client n, as many clients as I want. Now, let me just put this here to comments on that. I'm not going to use that right now. I just wait for the I'll just wait for one client, which is client 1. If I get client 1, then I'm done. I communicate here. Now the client is ready to exchange information. After this trip, see this trip, I start my client new socket localhost. I start this. Then I send the message. The TCP session will send a message to the server. It will go to port number 4450. It will not go to anywhere else. If the port 4450 has not been opened, if the server is not running, then this message will not reach. It will actually, there will be an exception. Now the server will take this message coming from the client, it will process it, it will decide to accept it whenever the time comes in. It takes as much time as it wants, takes this time, and then it sends back this message saying, yes, I do accept the connection here. Connection request is accepted. Connection request is accepted. And this is the total time. The total time actually is the two time, communication time, and the communication time, it can be broken into two different times. I will explain that later. Then there is the server processing time and the waiting time, all of this here. This guy right here. Okay. And then of course the message, the message time right here. During this time, all this T total, which is the T, now this is end, I think, should be. Okay, from T request to T end, the client can do absolutely nothing here. So I will make a comment here, and I will say the client is in a waiting state, waiting for the server to accept the request to connect. Okay, so this is the waiting time. Okay, that I will conclude this lecture with this. I just wanted to make sure that we understand what does inter-process communication, inter-process communication, okay, or they call it IPC. This IPC, how it works. Okay, let me stop right here now.